Okay, we have a question over here, and it's under the category of sliding window, or it is tagged as being a sliding window question and also an easy question. So the title of the question is find the k beauty of a number. So now let's read the question. The k beauty of an integer number is defined as the number of substrings of num when it is read as a string that meets the following conditions. Number 1, it has a length of k. Number 2, it is a divisor of num. Then given integers num and k, return the k beauty of num. Then what you are supposed to note over here is that when we have leading zeros, like what's the example, like this one, they are also like valid substrings of the num that we are given. All right, so because we are okay, what the question actually means is when we have a number that is given to us as num and we are also given the value k, we are supposed to find like a contiguous substring of length k from number or from num that is given, which is a divisor of the main number that was given. So when we take the substring of num, maybe 24, which is 24, then if we should, because 24 is like has a length of k, which is 2 items, so if we should take 24 and we should divide it, or we should find we should divide it by 240, are we going to get a remainder? If there's a remainder, then it's not a divisor. If we get 0, it means that it's a divisor. All right, so for this question, we are going to solve it using the sliding window. And the reason why we are using the sliding window is that we are dealing with a substring problem, and to solve substring problems more efficiently, the sliding window technique is quite one of the best techniques you could use to solve the question. Yeah. Into the how to understand the question. So first of all, we'll be given a number, then we'll be given a value k. Because you can't iterate through a number, you would have to convert the number into a string. Then in that case, you can iterate through the number and also slice the number into substrings of maybe length k. Yeah, so now let's go through the example that we have. We are given 240 and we are given the k value of 2. So we take the because the k value is 2, we only take the first two values of number that we are given after we convert it to a string. Yeah, so now we have the first two values, which is 24. When we have the 24, now we check if 240, or the number that we are given, is divisible by 24, which is in this case divisible. So we can increment the certain count that we set up that start from 0. So we increment that count whenever we find the k beauty of a number. So 24 matches the condition we have over here, so we can increment the count. Then we have the next set of numbers like in the continuous order, or like adjacent to each other. So when we take the first two, the next two is not going to be 2 and 0, it's going to be 4 and 0, which is 40. So when you have the string form of 40, then we'll check, is 40 divisible, is 240 divisible by 40? If it is yes, then we increment our count. Then at the end of the loop that we set up, we'll have the value that we are incrementing having the k beauties of a number. Now let's take the second example. When we take the second example, we have like 430043. That's like 6 values in there, and our k value is 2. So for the first iteration, we are going to check the first two values because k is 2. So we are checking the first two values. So 43, is 43 divisible by this huge number? All right, the code says it is. I have to go and do use my calculator and don't have that time. Then the next set of two values, which is 30. Is 30 divisible? Okay, it says no. Then because over here it says that leading zeros are allowed, then we could also like consider these two zeros and also like this one as well. So 0 0 is 0. So this one, if we should convert it to an integer back from the string, we are going to get 0, and we can use 0 for dividing and also like finding modulo as well. So this one is obviously a no. Then 04 is 04 divisible? It says no. Then 43, is it divisible? It says yes. So at the end of this iteration, we are going to have like 2 k beauties of that particular number that we are given. Go to the code implementation. So first of all, as I said, we would have to have like a variable that we keep track of the k beauties that we find. So that variable is going to be k beauty. Sorry. So that variable is going to be k beauty. Yeah. Which in this case we initialize to 0. Then now we have to convert our string, our number that we are given, to a string so that we can iterate through and also like apply some of the good things that comes with string. Then the next thing we'll do is to iterate through the number that we are given, the string that we have just converted. So when we iterate through it, through the list, then what we'll do next is we find a substring from that string of length k, or which has k values in there. So how do you do that? So this is how we do it. Come on. So now we find a sub number. Yeah, a sub number is basically maybe a number from the main number that we are given, but whose length is k. Okay, and this is how we find it. And after we find this sub number, we'll have to do some checks over here, because we can't divide, we can't find a modulo of 0, a number with 0 modulo, and also we can't also deal with empty strings. Then the other condition that we have is that the length of that substring should be k. So if we have anything matching this condition, then now we proceed down to the main thing where we find the modulo. So this is where we find this is where we determine whether a number is divisible by the main number we are given, if the sub number is divisible by the main number. So if we should find the modulo of number, the main number given, modulo the sub integer, the sub number that we are given, if it evaluates to 0, then it means that the number is divisible, or it's a divisor. But if we get any number aside 0, then it is not a divisor. So if we should find if the number modulo the sub number evaluate to 0, then we want to increase our k beauty, else we do nothing. Then at the end of our loop, at the end of everything, at the end of the iteration, our k beauty should have the number of k beauties from that main number that we have. So now let's run our code. Hey, why is it taking time? Alright, so as the code is running, wow, is it my network? Okay, I guess I just have to copy this code and refresh the page. Also find the runtime analysis of our solution. Okay, so we have all our test cases passing. Now let's submit this code and see if it will pass all our test cases. Yeah, it has passed. So now let's go through the runtime analysis. So this one have to do with like space complexities, which we are not dealing with, but we are just dealing with the time complexities. Yeah, for the iteration, like the for loop, the worst case that we could have is iterating through all the items, and this one will give us a runtime of n when we have n items in our list. So we have 5 items, the runtime is going to be O of 5. N in this case is going to be 5, so you are going to run the loop 5 times. Then if you have like 10, it's going to run 10 times. That's the worst case. Yeah. Then this one too is not counted because like there's a space complexity as well. Then finding the length of an array has a runtime of O of 1. Yeah, O of 1. Let me just write this in there. Yeah, O of 1. Yeah, so there's, aside these two, there's nothing to consider again. So because you are this is going to evaluate to something like O of n. Oh, come on. O of n multiplied by O of 1. The O of n multiplied by O of 1. And because in any case we are considering the worst case or the highest runtime, so the runtime of our code is just going to be O of n. Alright.